all of our work so far has led us to this part, and this is sort of one of the key things of this first chapter. How do we factor something bigger than an x squared, right? So what we're going to do to factor something fully is first step, we're going to find one factor and write the division statement. To do this, we're going to use the factor property. We have to use the possible factors of the constant term. The constant term, which I'm going to underline in yellow here, is the 2. So we can how can you multiply things to get 2? It's just 1 and 2, but it can be positive or negative 1, positive or negative 2. Those are your only possible factors. That makes this question actually really easy to factor. If the last number was 8,542, you'd be like, oh, there's a lot of possible factors that make that up. That would take a lot longer. A small number like this doesn't give us very many options. One of the things that we're going to do in these questions, just like before, helps us make our division statement quicker and easier to write, is let P of x equal this. I would use the remainder theorem for using 1 and negative 1, because it's easy mental math. I would use synthetic division for anything else. And we have to reuse synthetic division anyways to write our division statement, but it's really easy to plug 1 in. That will give me 3 minus 4 minus 5 plus 2. Does it equal 0? No. Unfortunately, it equals negative 4. So then I would say, oh, that doesn't work. I'll try a different one. This is the other one that I would do in mental math quickly and easily in my head. Plug in negative 1. What does negative 1 do? This will be negative 3 minus 4 plus 5 plus 2. It equals 0, which means x plus 1 is a factor. So step 1, we needed to find one factor, and we need to write the division statement. In order to write the division statement, we have to use synthetic division to divide. Question about the minus 1?
Yeah, minus 4.
It's still minus 4 because minus 1 squared would be plus 1 times by that negative 4. Now when we go to our synthetic division here, our original question was x cubed, 3 of them, minus 4, minus 5. Nothing is missing, so no zeros need to be added, and it was already in the right order. And if we're dividing by x plus 1, there would be a minus 1 out in front. Bring down the 3. Negative 1 times 3 is negative 3. Add them together. Negative 1 times negative 7, positive 7. Add them together. Negative 2. And this is what we were hoping, the remainder of 0. So our division statement is going to be x plus 1 times by 3x squared minus 4x minus, no, sorry, 3x x squared times 7x plus 2. So step 1 is done. We needed to find one factor and write the division statement. In order to do that, we had to use synthetic division to write that out. Step 2, you either have to repeat step 1, or if there's a quadrant, like sometimes you'll start with an x to the 4, you'll get one factor, then you'll get an x to the 3. Then you'll have to do it again with the new x to the 3. Or, if we get a quadratic, which is what we did, now you can use your regular factoring skills. How do you factor a quadratic? Well, 2 sets of brackets. The only way to get 3x squared would be 3x and x. The only way to get 2 would be 2 and 1, but it's going to make a difference if I write the 2 first or the 2 second. In this case, the 2 has to be second, so my outside makes 6, my inside makes 1. To get 7, they would both have to be negative. Double check that to make sure all the values work out. And we are done this question. But like I said, sometimes you're going to start with an x to the 4. When you write your division statement, you're going to get an x cubed. And then you're going to have to redo the process to find another factor that works for this x cubed part. Rewrite your division statement until you get down to a quadratic equation. So maybe this step 2 should say, repeat until you get a quadratic, then factor the quadratic. Questions for practice on this one? And I'd like you to try some of these. 5, 11. I don't know why I wrote these in such a crazy order. Maybe I wanted you to do 5 first, then 11, then 9, then 10b.